So differential amplifier is nothing but an amplifier which amplifies the difference between two input voltages. Okay, so differential amplifier is an amplifier which amplifies the difference between two input voltages. So the two input voltages will be V1 and V2. So one will be at the considered as voltage 1 and V2 will be considered as the voltage 2. So the differential amplifier is nothing but the difference between the two input voltages. So differential amplifier will be having a term called as VD and it is called as differential voltage. So differential voltage is generally calculated as VD is equal to V1 minus V2. Okay, so VD is equal to V1 minus V2. So when we consider the output V0, so the output will be always proportional to the input. Okay, so in whatever the amplifier we construct, the output will be always equal or it will be proportional to the input. So here the V0 will be the output and it is proportional to the V1 minus V2. Okay, so V0 is directly proportional to V1 minus V2. So V0 is equal to AD into V1 minus V2, where AD will be the proportionality constant. We have to remove the proportional. So to remove the proportional, we need to add a particular constant called as proportionality constant. So for that, we are using a particular proportionality constant called as AD. Okay, so that what happens, V0 directly proportional to V1 minus V2 becomes V0 is equal to AD into V1 minus V2, where AD will be your differential gain. Okay, so gain is nothing but the output voltage by the input voltage. Okay, so AD will be the differential gain. So what happens, V0 is equal to AD into VD. So V1 minus V2 is nothing but VD. So you substitute that particular V1 minus V2 is equal to VD. So this value V1 minus V2 value is equal to VD. Substitute this particular V1 minus V2 in here. So it is nothing but you'll be having a V0 is equal to AD into VD. So AD can be calculated as V0 by VD, where AD will be the differential gain and AD is equal to V0 by VD, where V0 will be your output voltage and VD will be your differential input. So when we take on this particular value, it will be given on the normal values. So we need to convert into decibel value. To convert decibel value, multiply the answer with the 20 log. Okay, so the answer will be in the normal value. To convert the normal value into the decibel value, multiply the given answer with the 20 log. So AD will be equal to 20 log AD in dB. In this particular session, we have discussed about this AD and it is called as the differential gain. Okay, so this AD is called as differential gain. And next topic we are going to discuss about the common mode gain. Okay, so next topic we are going to discuss about the common mode gain. So this is called as differential gain. So differential gain is AD is equal to V0 by VD. So next topic we are going to discuss about the common mode gain. So what is mean by common mode gain? So this particular common mode gain will occur when we apply same input voltages, that is when V1 is equal to V2. Okay, when you are applying the same input voltages to the amplifier, that is V1 value and V2 value are same. So what happens, other than this particular differential gain, we will be having a common mode voltage and it is called as VC. So what is meant by common mode voltage? The common mode voltage is a voltage which is nothing but the average values of the two input voltages. Okay, so the common mode voltage is an voltage which is nothing but the average values of the two input voltages. So VC is equal to V1 plus V2 divided by 2. Okay, so the common mode voltage is nothing but the average values of the common voltages and it is denoted as VC. So you can see here VC is equal to V1 plus V2 divided by 2. Okay, so this particular common mode voltage will be having an extra impact on the output. Okay, this particular common mode voltage VC will be having an extra impact on the output voltage V0. So what happens, output voltage V0 will be equal to AC into VC. So here in this particular scenario, the output voltage V0 will be equal to AC into VC, where this particular value AC is called as the common mode gain. Okay, so this particular value AC is called as common mode gain. So this AC value is nothing but the AC is equal to V0 divided by VC. Okay, AC is equal to V0 divided by VC and it is called as the common mode gain. the common mode gain is calculated as AC. It is nothing but the ratio of V0 by Vc. So the total voltage for the any differential amplifier will be V0 is equal to AD VD plus AC into Vc. The ratio of differential gain to the common mode gain is called as common mode rejection ratio, because we need to reject the common mode operation, because the common mode gain or the common mode operation will cause certain disturbances to the signal. So to avoid those disturbances to the normal output signal, we need to avoid this particular common mode operation. So to avoid the common mode operation, we are going for a ratio of differential mode gain to the common mode gain, and it is called as common mode rejection ratio, CMRR. So next is the general structure or the general symbolic representation of the BJT differential amplifier. So you can see here, this particular BJT differential amplifier will be having the two transistors in which emitter regions have been connected together. These two transistors are identical transistors. So we are calling as identical transistor because all the elements which is present in the two transistors will be same. So Q1, Q2 are the two transistors where the differential amplifier will be formed. So Q1 and Q2, the input voltages will be given at the base end and the output will be obtained at the collector end, whereas the emitter region will be connected together. This particular differential amplifier has the two inputs and two outputs, so it is called as balanced output differential amplifier. Since it has the two input, it will be called as dual input, and it has two output. This particular differential amplifier will be referred as dual input balanced output differential amplifier. Okay, since it has two inputs and two outputs, this particular differential amplifier is called as dual input balanced output differential amplifier. When we have only one input, we'll be calling as single input balanced output amplifier. When we have only one output, we'll be calling as dual input unbalanced output. And similarly, when we have one input and one output, we'll be calling it as single input unbalanced output differential amplifier. So based on the two inputs, it is called as dual. If we have one input, we'll be calling as single. And based on the two output, it is called as balanced. And if we have only one output, it will be called as unbalanced. So next will be the difference mode operation. So the difference mode operation, the values of V1 and V2 will be different. There will be a slight variation between V1 and V2. Since we are having the slight variation between V1 and V2, we'll be having the V0 value, and we'll be having the gain of the particular differential amplifier will be very large, and output will be obtained in the proper manner. Okay, so the difference between the two voltages V0, that is V1 minus V2 is V0, and it will be twice large as the signal voltage. Okay, so this particular difference between the two voltage will be twice large as the normal voltage, that is V0 will be V1 minus V2, and when this particular V0 is been amplified, we'll be getting the proper output of the differential amplifier. So the differential amplifier must be proper manner for operating in the differential mode operation. So in differential mode operation only, we will be getting the output in a perfect manner. Next one will be the common mode operation. So in common mode operations, what we have, we will be giving the same type of input to the both the end, whereas in the differential mode operation, we'll be giving the different input to the different type of transistors. But in the common mode operation, we'll be having the same type of input to the differential in the two type of transistors. So when we give the same input to the two type of transistor, what happens? We'll be having a common mode voltage, and as I said already, this particular common mode voltage will always causes some disturbances to the output signal. So it mainly causes some interference. Interference is nothing but collision of signal. Because of the interference, what happens is the output signal will be distorted and will be getting some unwanted signal as output, and it is called as an error signal. So we have to avoid this common mode signal. This common mode signal can be avoided by using CMRR, which is nothing but the common mode rejection ratio. The common mode rejection ratio is calculated as CMRR is equal to AD by AC. So the AC value must be very low, so that this particular CMRR will be very high, so that we will be operating this differential amplifier only in the differential mode. Okay, so you must note that this differential amplifier must be operated only in the differential mode or the difference mode for the proper output. Next, we are going to discuss about the configuration of differential amplifier. As I already said, this differential amplifier is mainly classified into four types: dual input balanced output. It be having two inputs, two outputs. Next one will be the dual input unbalanced output. So it will be having two inputs, one output. Third one will be the single input balanced output. It will be having the one input, two outputs. Last one will be the single input unbalanced output. It will be having one input and one output. So based on the input connections and the output values, we are classifying the differential amplifier into four types. Based on the given input connections, the differential amplifier is classified as dual input and single output, and based on the output voltage uptime, the differential amplifier is classified as balanced output and unbalanced output. So there are four types of differential amplifiers: dual input, balanced output, dual input, unbalanced output, single input, balanced output, single input and unbalanced output. So this differential amplifier plays a very important role in the operational amplifier to increase the gain and to provide the high input impedance and to provide the low input impedance. We will be using this differential amplifier. So there will be some two or more differential amplifiers will be used for constructing an operational amplifier. So all the differential amplifier must be operate in differential mode for the proper output of the operational amplifier. Okay, so with this differential amplifier, unit 2 characteristics of operational amplifier is over, and we can discuss unit 3, that is application of operational amplifier, in the next class. Thank you.